Hey everyone! In today's video, we are going to be going over and practicing our angle of elevation and angle of depression trigonometry word problems. So grab out your worksheet. You should see this picture exactly at the very top, including where it says your name, period, date. And we're just going to start off by reviewing what angle of elevation and angle of depression word problems are, and then get into each of the examples that you guys will be practicing today during class time. So, first things first is just to recap what we're doing. Whenever we see elevation, the word elevation, that means we're really just looking up. You'll notice on the picture on the left, there's a person who is looking upwards at the airplane, or similarly, if we move to the image on the right, if we are in the boat, we are looking upwards at the lighthouse. So that would be our angle of elevation. And if we are thinking about angle of depression, that is where we are going to be looking down. So just the opposite. Looking down at something. So in the image on the left, this person is looking down at the dog, which is so nice. Or if we happen to be at the top of the lighthouse, we would be looking down at the person in the boat. So that's really all we need to know about angle of elevation and angle of depression. That's going to help us when we make our right triangles in our pictures based on the word problems to make sure that we're labeling the angle in the correct spot. But something I just want to rehash really quick is even if you make a mistake on your picture, we know that we have two parallel lines. The horizontal lines are parallel. And when we have our angle of depression or our angle of elevation as seen in the picture on the right, both of the lines I drew in red and blue, that's my transversal, which means the angle of elevation at the bottom and the angle of depression at the top, those are alternate interior angles. And we know that those are congruent. So that means elevation in depression problems are like those angles are actually congruent, which is pretty cool. So either way we set up the problem, those angles are always going to be the same. So it kind of like gives you a little bit of peace of mind almost that no matter what you do, you can't really ruin it too much because the math should still be mathing, as they say. So let's get right into it. If you look down at your paper, you'll see these problems up at top, and then there is an example that is already printed and given to you. Whenever you have an example, the purpose isn't just to make you read more. The whole purpose is for you to use it to your advantage. So really quick, we'll see that this example says a water slide has an angle of elevation from its base to its height of 20 degrees. The slide has a height of 36 feet. The question is about how long is the slide? And this one's already worked out. But we can see that it says the water slide, so I'm going to use blue. The water slide has an angle of elevation, meaning we're looking up from its base to the height of 20 degrees. So I know I have a slide somewhere, and from the base to the height has my angle of elevation, 20 degrees. It also says that the slide has a height of 36 feet. So I know that that's going to be this side of my triangle is 36 feet. So the question is, how long is the slide? That means I'm going to need to figure out this side. Based on this, step 1 says draw and label a right triangle sketch. There we go. Step 2 said decide which trig ratio is going to help you solve the problem. And if we look at our problem here, directly across from my angle is my opposite side. Directly across from 90 degrees is hypotenuse. The one right next to is adjacent. From SOHCAHTOA, the one that uses O and H is sine. So we can see that we're setting up sine of my angle, 20 degrees, is equal to O over H, 36 over X. Then we would cross multiply and use our calculator to figure out what x is going to be equal to, and you would get 0.3420 is equal, like sine of 20. They did it with a calculator. They turned sine of 20 to 0.3420 and set that equal to the product, 36 over x. What I like to do is just cross multiply x times sine 20 equals 36. Divide both sides by sine 20, so we get x equals 36 divided by sine of 20. And when you do so, you should get about 105.263, this answer right here. And if we round it, that's about 105 feet. So this is a reference for you. If you get lost in the problems, look back at step 1, draw the picture and label it. Step 2, figure out which trig function you're going to use. Step 3, use the calculator to solve for x and figure out what you need to do for this. So let's get into it. On this worksheet, we're going to start off with a bunch of angle of elevation problems. These are probably the most common. I gave you guys 7, but I want to do one with you so you see what I'm expecting of you. You'll notice with this, everything's in a table. So on the left is the words. In the middle is where you're going to need to draw your picture that has a right triangle in it. And on the right is where we're actually going to solve the problem. So my advice is to always just like read the word problem, draw a picture that matches it and label it, and actually do the math in the far right column of solve. So let's do question number 1 together. Question number 1 says a slide has an angle of elevation, means we're going to be pointing upwards, of 25 degrees. It says that it is 60 feet from the end of the slide to the stairway. And the question is, how long is the slide? So I need to draw a picture of a slide. And usually a slide starts like there's like some ladder, some sort of like ladder system, and then you like go down the slide. Okay, now I know it needs to be a right triangle, so I'm kind of drawing it a little less curvy here. And it says that it has an angle of elevation of 25 degrees. And let's just make this the floor, right? So it told me that my angle was 25 degrees. And I know it has to be this angle down here. My pen will work. Okay. No, it needs to be down here. 25, because I got to look up at the angle, right? Angle of elevation means you look up, okay? It says that it is 60 feet from the end of the slide to the stairs. So if I look, this would be the end of the stairs to the end of the slide. So this part of my picture is going to be 60. And the question is, how long is the slide? That's this part right here. So step 1, remember, it says to draw and label a triangle. It's got to be a right triangle. Here's my right angle. Step 2 would be to label the sides. So x is my hypotenuse. Directly across from my angle of elevation is my opposite side. And right next to is my adjacent. Based on SOHCAHTOA, the one that uses A and H, is going to be cosine. So I'm going to set up my cosine problem. Cosine of my angle, which is 25 degrees, is equal to A over H, which is 60, over X. Are you serious? Sorry, I don't know why that wasn't drawing. So I set up my problem. I'm going to make it a proportion and cross multiply. 60 times 1 is 60. Then I will have x times cosine of 25. And my goal is to solve for x. So I'm going to need to divide by cosine of 25 on both sides. That means I'm going to have x equals 60 divided by cosine of 25. And I'm just going to let Desmos do the hard work. When I punch that into Desmos, that gives me about 66.2. And since we started off with feet, I'm going to put feet in my final answer. So the question is, how long is the slide? The slide is 66.2 feet long. And so as you go across these problems, questions 2 through 7, they're going to all be angle of elevation. So you're going to need to draw the picture in the middle and actually show the math on the right-hand side. And you might use sine, you might use cosine, you might use tangent. Remember, just use SOHCAHTOA to help you figure out which is necessary, and you have all of the tools to be able to solve. The next type of problems that you're going to be doing is angle of depression problems. And I didn't do a whole lot. I think I just did 4 of these. But these are still in the same setup where the word problem's on the left, the picture's in the middle, and the math for solving it is on the right. But you'll notice the word problem is absent for these. So what's kind of crazy is you're going to be given the picture, and you have to come up with the word problems that make sense, which is kind of nuts. Sometimes I like to start off with the math first before I come up with the word problems. I will say that coming up with the words is the most challenging part of this section, but it's really good. So let's just start with the math. Step 1, draw a picture. The picture's already there. So I'm going to do problem number 8 with you guys. Step 2 is to label the sides accordingly based on what we have. So I have angle 18 here. Across the opposite side of 18, we can see is labeled 60 meters. Directly across from my 90 degrees, that's the missing side that we're trying to find. That's the hypotenuse. And right next to is not helpful, but that's just like the horizontal distance from, this looks to be some sort of tower to some sort of fire. And based on having O and H available, this looks to me like I'm going to use the sine function, because sine is so O over H of our trig function. So I know that I'm going to use sine of my angle, that's 18 degrees, is equal to O, 60, over my hypotenuse, which is x. And it looks like the goal is to solve for x. So again, for this, we would turn it into a fraction and cross multiply. 60 times 1 gives me just 60. X times sine of 18 is on the other side, and I need to get x alone, so I'm going to divide both sides by sine of 18. Sine of 18. And x is going to be equal to 60 divided by sine of 18. Bust out the old calculators or Desmos, and this should give you 194.1, or maybe I'm just going to round it to 194. 194. It's actually 194.16. So maybe I round it to like 194. Maybe I'll just leave 0.16. Since we started off with meters, I should also continue my answer with meters. Now, the tricky part is writing a word problem that goes along with this. So I'm not going to have enough space, but maybe you say A person is in the tower and they notice that there is a fire at a campground. The height of from the floor to the tower is 60 meters, and the person in the tower decides to send down a bucket of water to put out the fire. They send down the bucket of water on a zip line. Maybe that's what it is. How long is the zip line distance? Like, that could be a question, right? You might even say, like, a park ranger sees a campfire in a national forest. If the angle of depression is 18 and the height of the tower is 60 meters, how long is the hypotenuse? Like, if you're having trouble describing what this is, like, maybe you just straight up say, how long is the hypotenuse? And you would have to write all of that information out over here. But I kind of like the first one I said, where there's a person in the tower and they notice that there's a campfire and they send down a bucket of water on a zip line. How long is the distance of the zip line? That would be this part right here. And that's what we found out. And we found out that that distance is 194 meters in length. But I will say the word problem part is pretty hard, and you actually have to write it out. I'm not going to for lack of space, and also my pen is kind of like wiggly, as you can see when I'm drawing straight lines. It's kind of like wiggly, but that's fine. Let's move on to the last set of problems that you're going to be practicing, and it's going to be finding angles. Okay, so it says, draw and label a right triangle to match the word problem and solve. So again, word problems on the left. We're going to need to actually draw the picture again in the middle and actually do the math on the right hand side. Let's do question number 12 together. It says, an ant is looking up at the top at your head. How the ant can see the top of your head, I don't know, but the ant is looking up at the top of our head. If we are 5 feet tall and the ant is 11.2 feet away from us on the ground, what is the angle of elevation from the ant to the top of your head? So, see, the question here is, what is the angle of elevation, which tells me that we're going to need to find theta. That's why this section's called finding angles, right? We also know that an ant is looking up at us. And we are 5 feet tall, and the ant is 11.2 feet away from us on the ground. So if I draw myself, again, not a great artist, but here's me, and I know that I am 5 feet. I know that there's an ant 11.2 feet away from me. And I know that this little ant is right down here. Maybe this is probably going to look gigantic, but he's got antennas, his body. There's my ant, okay? It's not great, but here he is. And he is looking up at me, up to see the top of my head. And the question is, what's the angle? What's the angle of elevation? If he's looking up, it's an angle of elevation problem, right? It even says angle of elevation. So now that I have this information, I can label. I have my opposite side and my adjacent side. That means we're going to use tangent. So I know that tangent of my angle is equal TOA, O over A, 5. Tangent is equal to 5. Opposite over adjacent, 11.2. And the goal is to solve for the angle. So I know I'm going to need to take my inverse tangent function. So I purposefully left some space. It's really important that you show taking inverse tangent on both sides. Otherwise, we aren't practicing good math. Inverse tangent and tangent, they cancel each other out, leaving behind just theta, the missing angle, and I'm going to type in inverse tangent of 5 divided by 11.2 in my Desmos calculator. When I do that, I get 24.05, and so maybe my angle of elevation is about 24 degrees. So that's what you're going to be doing, just filling out all of these. Make sure you draw the picture. Make sure you show all of the math steps. Don't skip any steps. And the hardest part you guys are going to have is coming up with those word problems, but please don't skip it. You're going to be taking pictures of this worksheet and submitting them, and this is going to be due by Sunday. I hope this video helped. Have a great rest of your day, but don't forget to complete the rest of the worksheet, submit it on Canvas, and don't forget to use this video if you get stuck or the example that we started out with. Bye.